Okay, hi everyone. Welcome back. So our next speaker is Cameron Vetter, a Microsoft MVP in the machine learning area, and he's been so kind to shift his schedule a bit earlier this session. Could you give a small introduction of yourself, Cameron?
Sure. So I'm Cameron Vetter. I'm based out of the USA in Wisconsin, and I've been kind of working within the Microsoft stack for about the last 20 years or so, kind of bouncing forward as Microsoft does. I've spent a lot of years, probably the last 6 or 7, working in Azure in some way, shape, or form, and now I'm spending a bunch of time doing machine learning within Azure.
Nice. Yeah.
So beyond that, I'm also involved a bit in the Lowlands.Community and really focused on enterprise architecture as well.
Oh yeah, so it goes all over the place. Yeah, I hardly ever hear the term HoloLens and enterprise architecture in one sentence. So that's I like that.
I move with what interests me.
Yeah, exactly. That's very good. Perfect. So when did you get started into more machine learning and deep learning topics?
It's really been just over 2 years. It kind of all started at a build a few years ago where I attended, and it seemed like everything that was being presented or announced was machine learning this or machine learning that, and I realized, wow, this is the space I should be getting into. So I kind of dove in head first and spent a bunch of time in TensorFlow and the Cognitive Toolkit.
Cool.
And that brought me here.
Very nice. All right. So you're going to talk about how to manage machine learning costs, which I think is a very relevant topic these days. So please take it away. The stage is yours.
All right. Thank you. Thank you very much. So this talk is kind of an iteration of a talk I was giving a year and a half, 2 years ago. The talk was really focused on Azure Batch AI, which is one of the many things that morphed into Azure Machine Learning. So this really brings it up and modernizes it right to the moment, as well as bringing some of the learning I've done since then kind of to the table. There we go. So my goal for this presentation is really to help you guys get a good understanding of how to apply Azure to machine learning projects with the goal of being either to save time or money, whichever is your priority. And in some cases, it will be both, but oftentimes it's a trade-off between those two things. So we just covered my intro, but I'll just toss out there. Here's some of the links, which I'll have at the end of the presentation as well. And I work for a company called the Octavian Technology Group. We specialize in data science, machine learning, and cloud architecture are the big things that we spend most of our time doing. So my roadmap here is I find anytime I'm doing a machine learning talk, it's really important to start out with a definition of what I'm talking about when I talk about machine learning. People have various definitions and various perceptions of what this space is, and that's because it is still a little bit fuzzy and vague. So I like to start off with that. Slide into just talking about what the Azure offerings are holistically in this space. And then after that, spending the rest of the time talking about how do we save time or money, or both. And I've got 4 examples of areas where I find that I'm able to save people a lot of money as a consultant in this space. So machine learning. So Wikipedia gives a fine definition saying that it's the scientific study of algorithms and statistical models. And, they go on, and there's a nice page about it. So that's kind of the boilerplate definition, but here's what I actually mean. I mean, we're taking some form of training data, and we're using that to learn and make decisions. We're using patterns and inference, so we're relying on those patterns and not using, these aren't explicit instructions or algorithms that we're coding out by hand. In the end, our goal is to get a model, and that model comes out of training, and that model is something that we then want to stand up to use so that we can do predictions or inference based on that. And I always like to highlight to people, this isn't just glorified statistics. I know this meme is finally dying down a bit, but for a while that was kind of the joke, was that machine learning is just fancy statistics, but it's not. This is really the union of statistics and computer science being brought together. So it's bringing a lot of statistical learning theory into computer science, and those things come together to provide us with machine learning as we look at it today. So that's kind of what I mean when I talk about machine learning and when we look at the rest of this presentation. So what are the Azure offerings? But first, here's a quote. I love this quote. It's from Satya Nadella. I've heard various versions of this many times over the last 2 or 3 years from him. But you know, he talks about what Microsoft is really trying to do is democratize AI. They're trying to bring it to every developer. They're trying to bring it out of that PhD ivory tower and something that's achievable for developers to integrate into their applications. And that should be for somebody that's both on a massive team at a big company and also for people that are at very small companies. I think that's really the key to keep in mind. If you've been thinking to yourself, oh, that machine learning stuff, that's for people at Fortune 500 companies. Well, it's not anymore. And a lot of the work that Microsoft has been doing has been bringing that to everyone. So the first place I like to start is cognitive services. And the reason I start here is because this is the least investment that you can do. And this in and of itself is kind of a tip. If you're starting to think about how do I apply machine learning to my company, and so often we go in as a consultant and hear, well, the CFO read an article and it said that everybody's doing machine learning now. We should be doing machine learning. Why aren't we doing machine learning? And then we get pulled in as consultants to kind of address that situation. This is usually where I try to guide people, is take a look at some of the stuff that's off the shelf that you can use to solve these problems with minimal cost to the company. It allows you to kind of dip your toe in and get a feel for the space and start to bring some benefit before you've even really spent a lot of time building your own custom models. These are often domain specific. So these are things that, you know, very common scenarios that they're solving. And Microsoft claims to, and I would agree, have the most comprehensive portfolio of these on the market. So they've got probably about 28, I think, at the moment. And each one of these solves a problem or group of problems that are fairly common across many different verticals and many different industries. These services are designed to be deployed anywhere. The common use case is to deploy them in the cloud, but you can also go as far as to deploy them into containers and place them on edge devices. And there's no real expertise required here. These are things where you're matching up the use case and then just learning how to interact with that service that's already trained and already ready for use. So next is the Azure ML Designer. So the ML Designer is really kind of a drag and drop experience for building out your machine learning. So now we're getting to a point where we're building something that's custom built for our domain and something that is focused on solving a problem that's specific to what my company needs to solve. So what they've done is they've provided drag and drop pre-made modules that you kind of drag and connect together. And these modules do various things like help you work with the data, they help you perform training, help you do scoring and validation. So this tooling is really handy for people that may not be coders, but are highly technical. So maybe people with math degrees or PhDs in related fields that want to work in this space. This kind of takes a lot of the coding out of it. It doesn't remove all the coding. When I've used these things, I found that to get anything practical done, I often have to resort to doing a couple things in R or Python. But for the most part, it's a drag and drop experience. So next is a fairly new offering, which is AutoML. So this really is the epitome of democratizing machine learning. So what they've actually done within Microsoft Research is they've built machine learning that helps you build your machine learning. So essentially, as you do a training, the machine learning then takes a look at the results, and based off of that, it decides what angle to pursue next. Now, it might be a totally different path, a totally different model. It might be tuning the hyperparameters in a different way, but it decides that for you, and it iterates very, very rapidly. So the last thing I did with this, I set it up, let it go for an hour, and it came up with 44 different models that potentially could solve my problem. And it's a fairly easy thing to do and to roll out, and something that is easily attainable by somebody that doesn't want to get an expertise within the machine learning space. The trade-off for that, though, is that you get a very specific set of use cases. So the problems that it's really designed to solve are classification, time series forecasting, and regression. The good news is, though, that space, it represents a whole lot of very useful problems that can be solved. So it's another great tool to have in the tool belt that can help shorten your time to developing your machine learning. Then we have Azure Machine Learning as a service itself. So the idea of this is that it gives you kind of a place to build out your machine learning, to do the entire workflow, and we'll get to that in a second. But I kind of separate it out into, there's two different levels of doing development. There's the high level. So in my example of that is Keras, which is the library that I tend to use. But so this is a library that sits on top of TensorFlow, Cognitive Toolkit, and a few other ones. And that it has a lot of neural network stuff that's pre-built and ready to use. So again, you don't have to understand how to implement those various neural network components. Now it's more about how do I plug those things together to get the result that I'm looking for. So, and it really empowers developers and data scientists to move forward much more rapidly. And by doing it in Azure ML, now I don't have to worry about all of the nonsense of building out my environment and trying to get all the dependencies right and all of the complexities of getting a machine learning environment running on your local machine. So you can get to the actual meat of the work much more quickly by using Azure ML. Yeah. So next is kind of at the lower level. So when I talk about the lower level, I mean things like TensorFlow or PyTorch. So these are the libraries that I like to say it targets researchers. It really targets researchers and some very experienced ML engineers as well. But these are libraries that really are focused on providing you the tool set necessary to implement these different components and then assemble them together yourself. So, and these are all are tensor focused. So they're really designed on working to work with multi-dimensional rectangular arrays of numbers and being able to perform operations on them. And this is what, when we look at today's modern GPU, what it's really focused on accelerating when we start to apply GPUs into machine learning. This is what they're accelerating. And this is very low level. So this is a symbolic math library, really, and it's just focused on this specific use case. And the reason I picked these two is TensorFlow is by far the dominant force in the marketplace. But PyTorch is another very popular one. They're by far the two leaders in this space. So, and that really brings us Azure Machine Learning, which is, this whole set of tools that are available in the cloud, and they help us to manage the entire process as well as to actually do the work of the process of doing machine learning training. And so one of the key things I like to always bring to people's attention is what you're really doing, what your end result with Azure Machine Learning is I'm building machine learning as a service. So my end result is going to be a service that I stand up that somebody else can consume. So it's going to be simple, it's going to have a RESTful interface to work with, it's going to be encapsulated. So I'm going to keep that separate from the rest of my code base so that there's clear boundaries, and that helps to make sure that people that are not interested in the machine learning side of things are able to easily consume it. But if you need it to be, it can be integrated, and you can pull that stuff down to your edge device and run that locally on your edge devices, or put it within containers to have some logical boundaries. So I think that's one of the important things that people often forget about with Azure Machine Learning is the end result is that I've got some machine learning as a service is kind of the end result. The other really key thing I like to point out to people is that it provides you with a workflow of Azure ML Ops. So this is kind of also a little bit of a hidden gem in here since we didn't truly get to the cost savings part. But doing Azure ML Ops well will help you save a bunch of time and money because it's all about using DevOps type of tactics to actually train your model, package it, validate it, deploy it, and monitor it. And it provides all the tooling to integrate in with Azure DevOps and to provide that workflow. So that's kind of the entire, the big tool set that we have available to us within Azure to do machine learning. So that brings us to the kind of the point of the talk, which is, well, how do I save some time and money? And my first piece of advice is really is relevant outside of Azure, but I think it's very important. So I wanted to throw this in there, and it's start small. Work smart, save money, right? Start off looking at pre-built ML services. So often we'll go to a client and hear their story of what they want to do, and they have this big vision of how it's going to revolutionize the entire company. And it's going to be this massive set of different machine learning models all working together to connect a flow. But realistically, a project like that could take years, and it's not where you want to start. You want to start with something simple that gets you some quick wins. It shows you that this is something you want to invest in. From there, then start taking a look, well, are there some pre-built neural networks out there? Is there stuff in the world of GitHub and open source that I could apply to this problem and maybe doing just my own training? And then from there, is there, can I do a proof of concept doing some using high-level libraries like Keras that we talked about earlier? To build out your own neural network and to do that training, now getting into some of the more complicated, more technical work. And then finally, my advice is don't chase after, even when you're going after these big elaborate solutions, don't chase after the low-level libraries unless you really, really need to. Something forces you in there. Oftentimes the high-level libraries will allow you to do some customization that extends beyond its boundaries so that you can solve problems that you would typically only chase with low-level libraries. But anyway, this is kind of my general advice as I meet with a team that's starting to think about how they're going to plug into machine learning. Make sure that you start simple and work your way up and build up to the big complicated solution. Don't just start at the complicated side. So in the spirit of that, cognitive services, right? Can you think of some use cases within your business domain? So I picked 9 of my favorites and just threw a couple of use case associated with each of these. So there's so many more use cases for each one, but I'm just trying to get you to kind of stimulate your imagination a little bit. So the first one I'll highlight is computer vision. It's always the flashy, fun one, right? When you're analyzing images. So, is there something you can do by labeling some images? A great example of that I did with Custom Vision is a manufacturing company that was manufacturing parts. And can we take a picture of the part on the line and decide whether or not that part has any manufacturing defects in it? So kind of an example of how you turn that into something within a domain. Text analytics is another great one that I'm using in a project right now, actually. So, excuse me. So with text analytics, we can detect sentiment. We can find key phrases, and we can generate named entities. So that's actually identifying what different components are of the text that you're analyzing. So this can easily be applied to many different domain problems where you have a chunk of text and you need to analyze it, whether it's taking a look at the text that's coming into your support people to determine if the customer's happy or unhappy. That would be a great example of using some of the text analytics. And the third one I'll highlight is a fairly new one called Personalizer. So Personalizer is really about collecting data as the user experiences some part of your application, typically a web application. And then as you're seeing how they use the application, actually customizing their experience so that they might get a slightly different screen that's more applicable to them the next time they use the program, or something else might be brought to their attention that's relevant based on what they're doing. So these are all great cognitive services, and there's a bunch more. So really take a look at those and start there. It's easily achievable to build out a prototype of a concept within just 1 week's time. So it's a great way to save both time and money by getting that concept together more quickly and less expensively. So my second example, get a little bit more concrete into Azure specifically. So when I'm doing training of a machine learning model, this tends to be a very long and expensive process. Oftentimes, each individual training cycle might take 5, 10 hours to execute. And it might be something that I do 20, 30, 40, 50 times before I'm actually done building out a model. So Azure ML has a big focus on helping to work within this space. And they do it through 3 different concepts. One is compute. So these are clusters of VMs that are actually applied to solving your problem once you submit a unit of work to be executed. There's the management of data sets. So once I've put together the data I'm going to use for my training, it brings it all together into what they call a data set that also has a version, which can then be used by the compute when it's executing the experiments, which is the last one. So the experiments are a group of trainings that make up, chasing a particular solution. So all of these things put together is kind of how we get to do training within Azure ML. And we typically end up using what's called Azure Data Science Virtual Machines. So these are special VMs that are customized and pre-installed with every popular ML tool they could think of, basically. The picture on the left here kind of highlights a big chunk of them, but there's still a lot more. Even than this, and what's really nice about this is it's really, really hard to put together a machine that can execute just on one stack of data science. You know, if you're going down the Keras TensorFlow, as I often do, right? There's a whole lot of things you need to install and get matching versions, or things don't pan out well. But so that's already solved for you, and not only is that solved for you, but there's also a dozen other frameworks installed and working, and with all the correct compatible information there. So when we put together those compute clusters, like we were talking about on the previous slide here, so those are typically made up of data science VMs, although they don't have to be. But usually that's what they're made up of. So let's take a look at the cost. So here's an example of some costs of doing what we have. Sitting at my desk for, taking a look at this. Boy, that doesn't really look great. I did these over Windows. Hardware that's this bleeding edge is probably only going to have about a lifespan of 2 years. So you can see, looking at it just very at a very high level, it seems like it's way more expensive to do this in the cloud. But the realities are actually quite different. So if I take a look now and realize, well, I don't just have one person on my team. I actually have a team of 4 people. When I'm working within the cloud, they can submit their jobs to the same cluster, and all of them are sharing the same set of hardware. In the office, probably not as easy to do, and I most likely at some point would end up with 4 complete setups. So right there, now all of a sudden the cloud is looking like a much more appealing option, but that's still a little bit of a stretch here. So let's take another look. Now, realistically, I'm not using those machines 24/7 all the time, having them crank away on a problem. So just for the sake of this comparison, let's say that we only have them busy 1/2 of the time. Well, suddenly now that just cut my costs in half if I'm in the cloud, but if I'm using physical hardware, it's still the exact same cost. I just have idle equipment sitting there. But the real thing that makes the cloud so appealing and so helpful with costs is the concept of low priority VMs. So Microsoft has this concept of you can either get a VM as normal priority or low priority. So the costs we were looking at before were normal priority. So you'll notice it's $657 per month. Now, if I get that same VM as low priority VM, it's $132 a month. So that's already a huge savings. Now, compound that with the idea that I'm not going to be using it full time and my entire team can share that. Suddenly, I've got a 2-year cost that is extremely low compared to the cost of doing this on physical hardware. So this is one of the key points I want everybody to walk away from this talk with is if you configure your Azure Machine Learning compute correctly, you can save probably about 80% of the costs versus just naively assigning one machine at normal priority to it and leaving that machine engaged all the time. And what's really nice about Azure Machine Learning is you can tell it, I want to have a cluster, and the cluster can range from 0 to 5 machines, and it will scale up and down as demand requires. So the net result of that is it sits there at 0, you submit a job, and your equipment actually spins up, it does the work, and then it spins back down, so you only pay for that chunk of time. The one disadvantage you get is that you're waiting for that to spin up. And if you're using a low priority VM, it can take quite a while to spin up. I've waited as long as 20 to 30 minutes for a VM to become available to me. But when you're doing something that's like an 8-hour training, it really doesn't make that much difference, because usually I know I usually aim for those trainings to happen overnight anyway. So it doesn't really matter to me if it took an extra half hour to start up. However, if that does matter to you, there's the opposite side of this, which is you can save time instead of saving money. So this is the pricing as of 2 days ago, which is constantly in flux, but you can see the difference between low priority and normal priority. So maybe when you need to save time, you switch to a much higher instance with more GPU and more memory and more storage, or maybe you just shift over to normal priority. But the nice thing about being out in the cloud is maybe you've been running for a while with low priority VMs and doing it very economically, but then you get to an urgent situation and now you need to go as fast as possible. Well, that's no problem. Just pull a couple levers and suddenly you have 5 times the horsepower and it's just ready to go at any moment. So that brings us to tip number 3. And I wanted to start out with just kind of a look at what's going on right now when we look at machine learning projects. So, and it's kind of grim when I looked at the data. And so the data I looked at, what it showed is that 78% of ML projects stall. And often when they stall, they just stop permanently, and nobody figures out how to get them going again. Gartner predicts, and this is for the coming year, that 85% of machine learning projects will fail. And when we take a look at how long does it take from concept to gain to production, the average is 60 days, but there's a whole lot of projects that take close to a year, and even some that take longer than a year to get there. And we're still in the infancy of doing ML enough that most projects, 63%, are the first time that a team has taken their project all the way to production. So how does the average ML team spend its time then? Well, they typically spend 54%. And this comes all from a Kaggle survey, by the way, which I've got the source listed on the slide. But they spend 54% of their time gathering, cleaning, and visualizing data. I always joke that 80% of machine learning is being a data janitor. And there is some truth to that. You'll spend a lot of time working with data. But then 20% is spent building a model, and 26% is spent doing hyperparameter tuning, so adjusting that model to get the best result possible. So that brings us to automated machine learning. So the idea behind automated machine learning, we mentioned it a little bit earlier, but this is a way for non-professional data scientists or professional developers to build out machine learning models, and to do it very rapidly by automating the time-consuming and iterative tasks of model development. I think I mentioned earlier, so I recently did a project using AutoML. So it took it 1 hour to test out 44 different models for me, and then to highlight which is the best one. And what's really cool that's baked into automated machine learning at this point is there's a lot of information that's being presented to the end user of telling you why the model works the way it does, and giving you advice of what's wrong. For example, it will try and tell you if there's something wrong with your data set, if there's not enough of it, or if it's heavily biased towards one direction or another. Those sorts of things are baked in. But so if there's an opportunity to use automated machine learning, that can be a big time savings, because when we go back to this slide, you still have to do the data work, but the model and tuning generation are done for you. So you can peel a lot of time off of a project if automated machine learning works for you. So that's another great way to save some time and money. And my final tip is focused on saving money. Um, and to get into that, I want to talk a little bit about bias and variance. So bias is when you underfit. So this is when you're doing a training and you have you may not have enough data or some other reason that you're not actually fitting the your curve to the actual data set. So the net result is that your solution is going to work really well within that space, the training data set, but may not work as well on the result. And when we think of bias, oftentimes we think of things like, well, let me give an example. Maybe that will be a little bit clearer. An example of bias might be if we had a loan that we were using machine learning to decide who should get the loan. The machine learning might have a bias to give the loan to males over females. And that's an example that's actually used in some of the tooling we'll talk about in just a second. So being able to identify that and solve it can be is very important to your machine learning. So variance, on the other hand, is getting sensitivity to the data set. So looking at the picture, the idea is if you were training it to identify trains, well, if you had high variance, it would actually train more towards the noise in the picture versus training to the actual picture of the train itself. So that's called overfitting. So these are both problems that we face in machine learning, and these are, it's really important that at least one person on your team understands these problems, because the net result is there's some great ways to lose money here. Ranging from costly errors. So what if I manufacture the incorrect products, or too many or too little because my ML had some issue with it? Or what if I get bad publicity? I mean, I always come back to the story that went around a year or two ago about Amazon when they were using ML to filter out their resumes. And it turned out that they had really bad bias towards males in that machine learning. So that turned out to be really bad publicity for them for at least a little bit of time. And the final is it could even go so far as lawsuits. It could be construed as negligence, and it could lead to some time in court. So these are things you really, really want to avoid. And luckily, Microsoft has brought some solutions to this problem. The first one is Interpret ML, which they've integrated into Azure Machine Learning. So the idea of Interpret ML is it takes the black box that you get out at the end, which is a model, and attempts to turn that into a glass box. And it does that by kind of revealing some of the details of how the model works and why it works. And it helps to detect fairness. So does my model discriminate is the first question, and it helps you to do some what-if scenarios. And if it does, it helps also identify why. It helps you with debugging, so understanding why a model made a mistake. And it can also be used to satisfy some legal compliance requirements if there's some regulatory needs. Having this additional information can be enough to explain how the model works well enough to satisfy legal compliance requirements. And the other tool that they've been integrating in is called FairLearn. And by the way, both of these are open source projects, so you can check them out independent of Azure. But they're starting to bake these and bring them forward in Azure Machine Learning so that you don't have to do the work of integrating and making them work. They're just additional information that's available to you. So FairLearn is really focused on trying to find allocation harms. So they're trying to identify, when there's something in the model that's unfair, that could cause you to not hire some person, or for a person not to get into school or not to get a loan. This is the one that has the loan example as one of their examples. If you check out their GitHub project. And the other is quality of service harms. So is the model reducing people's opportunities to acquire resources? Or is information not making it to the person? So these are the things that it helps chase. So if we come back to this slide, the goal would be, don't have these things happen, right? Don't have these costly errors, don't have the bad publicity, don't have the lawsuits. And these are some tooling that can help you. But ultimately, this stuff it all comes down to your team, and your team being focused and aware of this situation and these needs. So in summary, what did we just look at? We looked at we talked a little bit about what I mean by machine learning, what the Azure offerings are, and then we covered 4 different ways to save time and money. So that brings me to the end of the presentation portion here. My LinkedIn is on screen, as well as my Twitter and my blog, if anybody would like to reach out or connect with me. But does anyone have any questions?
Thank you very much, Cameron. This was really a very extensive overview of all the machine learning capabilities of Azure. It's really some new ones for me even, so thanks a lot. Also nice that the fair learn was pointed out again, also earlier by a session by Willem, so nice to see that highlighted. I do have a question about, there was a slide about the percentage of machine learning projects stall and the percentage of it failing. Do you know the reasons why they are being stalled or why they are failing?
Yeah, so what often happens, and I don't want to throw data scientists under the bus, but oftentimes what happens is a data science team might come and put together a model, and it does solve a problem, but they haven't really thought through how you actually bring that to production and productionalize it. And there can be reasons why it's not realistic. Maybe it's too compute intensive to actually have working against your production, or it just there may be many other reasons why when you get to the machine learning engineer doesn't know how to actually make this something that's usable in the real world. But that's one of the reasons. Another reason is this is a really highly experimental space. If you're doing a custom model, there's always a chance that you don't have the right data, or the data shape is incorrect, or there's some other major problem that prevents you from ever getting to a model that works. And that can often kill a project, even if the answer is fairly simple, like we need to go collect data for another year. Oftentimes that can be a showstopper on a project.
Mm-hmm. Yeah, good points. Thanks for filling that in. One question I have, which also maybe more towards your career, but maybe you can help others who are maybe now a developer but want to move into data science. And so how did you move into data science, and do you have some tips for newcomers to this area?
Yeah, I actually started very simple. The very first project I did used a whole bunch of cognitive services and assembled them together. So it was kind of a nice first step. But then after that, when I realized I wanted to learn how to do it myself, I got out there and I learned how to use TensorFlow and Keras. I happened to pick up a course that I worked through that kind of got me started. And then after that, it was just like anything else I do in my career. I spend a lot of time on Google trying to learn about various concepts as they come up, or and everybody learns differently, but however you learn, go out there and do that. There's so much information out there. A great resource is there's I don't know if it's really a blog, but it's towardsdatascience.com. Okay. So if you go check that out, they have a constant flow of great information. I could learn something new every day if I had the time to read all the content that they put out there. So that's a great place to take a look as well.
Excellent. Yeah, thanks for pointing that out. Also, that blog. I totally forgot to announce our host, Kim Noel. So maybe you can give a short shout, Kim.
Yeah, for sure. Hey, everybody. Actually, I had a question for you, Cameron. You listed about, I think you said 9 cognitive services on your slide. Do you know just how many exactly there is? Or is that just like always growing?
It's always growing, but I think last time I counted, there were 28 of them available. But that's a little bit deceptive because some of them actually have multiple capabilities. Like some of the language ones are able to do sentiment analysis while identifying entities and things like that. So it's even really greater than the 28.
Right. Okay, cool. And do you have it, because you said those 9 were like your favorite. Do you have any that's maybe your least favorite? Or anything like that? It's not a trick question.
There's nothing there's no cognitive service I've worked with where I've said, oh, this is terrible, I don't ever want to use this again. There's some that I haven't had the opportunity to because they haven't applied to any problems. But yeah, nothing I can think of that I would tell people to stay away from. They all tend to be very well researched and well designed.
Oh, okay. Nice.
Excellent. Okay, well, thanks a lot. I think we're ready now for a short break before we go to our next speaker, Sean. And any other comments you wish to make or announcements, Kim, or are we good to go for a break?
No, just thanks, Cameron. That was a great session. Thank you.
Thank you.
Thanks. See you in a couple of minutes then.